Here there is a small particle of mass m is moving such that its potential energy is given. Okay, so potential energy is half m omega square r square. இப்போ வேறு என்ன கொடுத்துருக்காங்கன்னா, if r is the distance of the particle from the origin, assuming that Bohr quantization of momentum and circular orbit, so Bohr's quantization condition is what? L, which is equal to mvr. So and then radius of the circular orbit will be proportional to what? This is what we have to find. So first, using this potential energy, what we can find the force. Okay, so how we can find the force? So minus of du by dr. Okay, so here if I differentiate this r square, I'll get 2r, 2 and 2 will get cancelled. We will get minus m omega square r. Okay, so now if you have an orbit, your electron will be revolving around this in a circular path. So your centripetal force will be equal to your force F here. So we can say mv square by r, which is equal to minus m omega square r. So here if you see, m and m can be cancelled. Your v square or v can be written as root of your omega square r square. Okay, this is what the value of velocity. So we can write it as omega r. This is what the velocity is. So now if you use your Bohr's quantization condition, what we will get? Angular momentum, which is equal to mvr. So here your v is nothing but omega r. So m into omega r into r. Okay, so this we know, your angular momentum is always nh by 2 pi. Okay, so now, so here I have r square, you can bring m omega square in the denominator, r square, which is equal to nh. Okay, nh divided by 2 pi m omega. So your radius will be root of nh by 2 pi m omega. So in this, if you see, h is constant, 2 pi is constant, mass of your electron is constant, and omega is also constant in a particular orbit. So we can say your radius is directly proportional to the root of your n. So your answer would be this.